humidity. It's going to be a light day today. So we're not going to have 1 million people because it's a 3-day holiday weekend and people are out doing stuff. And that's okay. We're going to roll with it, and they'll catch up with us later. Okay, now I'm getting positive feedback from YouTube, so I think we're healthy. Let's see. We had an earlier report from Brooklyn, New York. Let's see if I can get it. Brooklyn, New York, 87 degrees Fahrenheit with 51% relative humidity in Coney Island, Brooklyn, which, by the way, is my hometown. I am from Coney Island, Brooklyn. Okay. DBX, no worries. You were actually correct. Indiana John is here, 79 degrees and sunny in northern New Hampshire. Are you on vacation or what's going on? CJ Stevens reports 84 and beautiful in East Tennessee. Almost Machining, 92. Now, when Almost Machining checks in with 92, that's more to be celebrated than anything because it was 192 earlier this week. Joel L., a refreshing 93F, 52% relative humidity in the Chandler, Arizona. Welcome aboard, sir. Well, we'll have some fun today. As you guys might know, we have Adam Balogh. Adam is from Laney Machine Tech out on the other coast, and we're going to have some fun with him today. Blake reports Rochester, New York, 78 Fahrenheit and 56% relative humidity. Flat Lapper is here. Welcome aboard, sir. 85 and mostly sunny in northern Illinois. Outstanding. Well, it's been a weird week. A lot of things got done, and we will talk about it. But I don't want to delay bringing our guest in. He can handle the randomness here, so we'll just bring him here. Let me just click this thing. Can you? Can you hear me? Can you hear me? Oh my gosh! Yes, I understand you're sitting on a satellite orbiting the Earth. Is that true?
That is correct.
Okay, I feel better now. Actually, you're not allowed in until you give the password.
Weather report, is that the password?
Yes.
So about 65 degrees Fahrenheit. I'm being told 75% humidity here in the Bay Area in California.
65?
Yeah.
That's stunning.
Yeah, it's pretty comfortable. Slightly overcast.
I didn't expect that. I'm not going to lie.
Yeah. It's been kind of weird. It's been kind of weird lately.
Okay. Sounds actually quite pleasant to go wander around.
At the moment, yeah.
Daniel's checking in. 75 Fahrenheit and surprisingly sunny in London, the UK. Welcome, Daniel. Thank you for that report. It's been quite nice this week, and today we're going to hit 84 degrees, and I think I'm going to get a little bit of sitting in the sun and just baking for a few minutes. However, I should report that I have been in IKEA hell, and if you don't know what that means, you have not had enough hex wrenches dig into the palm of your hand. My kiddo, Sam, who you've met on this stream, is in art school down at Tufts, the School for the Museum of Fine Arts, and got her first apartment. So this was the move-in. This was build all the IKEA furniture, and that was yesterday. If I were to tell you that I'm not exhausted, I would be lying. And guess what I'm doing this evening? Going back for more. So we're definitely learning from IKEA. IKEA has a strangely good product engineering capability. I mean, it's just amazing. And their little widgets, their little fasteners are all custom. And the little things you turn to pull in the little stud and do all that stuff, that's all cast and custom made and brilliant. Absolutely brilliant.
It's pretty amazing.
It is pretty amazing. So as long as it holds up the kid's bed, I'll be happy.
It probably
Oh,
will for exactly the amount of time that your kid is in college, and then will immediately break.
4 years and one day. It'll just,
Exactly.
yeah. Let's see. DBX has given us a report. 85 Fahrenheit, 50% exactly relative humidity. And he says, I refer to this as disgusting in Rockland County, New York. Dan, welcome. Thank you. Dan, by the way, is the stream audio engineer. And I appreciate all of his efforts into getting us sounding better. Robert Simpson checking in at 86 degrees and overcast near Detroit. I appreciate the fact that you're not admitting any more than that. You are near Detroit. So, yeah, we're going to have a good day before the barbecues. Thanks for coming, Adam. I appreciate it.
Oh, yeah, absolutely. Very happy to be here. Thank you.
I was so excited to see your recent Instagram post with respect to the new microscope.
Mm.
And I thought it was, I was kind of sitting there and you were all excited about this dude. And I was like, it's not a Nikon, dude. It's not a Nikon. It's not a Nikon. But
I had to break my brand loyalty.
Yeah, I will allow it. I mean, any optics is better than no optics, of course. But I was super impressed. I really liked what I saw. It made me want to go buy plane tickets. That was really fun. So, explain for the folks that have joined us here but haven't seen your posting, just explain the recent acquisition.
Yeah, so this is one of the pieces of equipment that we've been acquiring in order to teach the micro machining and ultra precision machining curriculum. This most recent one was an Olympus STM7 measuring microscope. So imagine it's like a toolmaker microscope, right, where it has a stage that has some way to track movement of the stage in X and Y.
Mm-hmm.
But this also adds measurement software capabilities. So just has a PC that's attached to it. The control box actually does a lot of stuff to be able to link up the multiple systems on the microscope so that you can do on-screen measurement, both in and out of the field of view. So there's like the glass scales on the stage, which read down to 1/10 of a micron. And then there's, I know. And then there's also
it's merely 1/10 of a micron.
It's really quite impressive.
Have you changed your definition of tenths? Now, yeah. when you say, "Oh, we're within a couple of tenths of a micron,"
yeah, I have a few students, who will see a digital readout like that, and it just looks like any old digital readout. And I'm like, hold on, though, that's in millimeters, man. So that's 4 millionths of an inch. That's a shocking level of precision.
Yeah, it's just amazing. A couple of check-ins here. Machine NZ down in New Zealand. We keep him from getting to work on time. This is a tradition. He's reporting 11 degrees C and expecting rain. Notice the numbers here. Can we just point out that, first of all, since the Earth is flat and he's on the other side of the Earth, he's holding on for dear life, and it's still 11 degrees C and expecting rain. Tucker is here from Buffalo, New York, 82 and sunny. It's sunny in Buffalo. Again, he's burying the lead here. And Indiana John says, like an optical comparator?
Yeah, basically.
It's like an optical comparator on steroids.
The magnification is much, much higher, and you can use more than just transmitted light. So like an optical comparator always looks at the profile, although you can sometimes do reflected light on an optical comparator, but it's usually not as good because on an optical comparator you have to have fiber optic cables that you shine onto the front, but you rarely ever have the light coming in perfectly incident, orthogonal to the thing that you're looking at, because it's just not included in the beam path. whereas a microscope would be. So there's
Yep.
an illuminator and a beam splitter, and so you're actually looking straight down on it. So yeah, so you have both of those capabilities. So kind of like a digital optical comparator in a way, where you can also look at profiles that don't go all the way through the part, if that makes sense.
I loved what you said about measuring Z with focus, which is something that
Mm-hmm.
microscopists have always done. Getting things in focus. And what kind of accuracy do you think you're getting with that technique? Because it does depend a little bit on the operator, right?
It's really subjective, and that's kind of the problem. It's less subjective when you have built-in autofocus, right? But when you're just using, a human operator, then it's pretty subjective. And the higher magnification objectives have a narrower depth of field, and so it's maybe more obvious what in focus is.
Mm-hmm.
But even then, I mean, it's a few microns.
So, when you're talking about half micron resolution, we're down to where the wavelength of the light you're using is in the neighborhood. Visible light is 400 nanometers, which is 0.4 microns.
Mm-hmm.
And so we're there, right? You're talking visible light wavelength resolution, which I might say is nuts.
I suppose that's true. Yeah. I mean, the glass scale is like it's a mechanical measurement, right? So how exactly it factors into the optical system is not super clear to me. There are like three systems that need to be linked up for this thing to work. There's the glass scales, and then there's also the objective lenses themselves, and more specifically their exact magnification. And then there's also the CCD sensor in the camera. And so when you calibrate this thing, the scales get calibrated, but then also you have to calibrate, like, using one of those low reference microscope slides. You have to calibrate a known distance and link it up to a certain number of pixels that it covers on the CCD with each objective, so that you kind of link the pixels and the magnification of each objective. But then the crazy thing to me is that it then also is able to link that to the scales, because if you only link the objectives and the CCD, then you can measure on screen, but you can't measure outside of the field of view. That's where the scales come in. And it somehow links all of that up. And that is also not clear to me, but I've measured many things with it, and it's good. I mean, like, verify it compared to mechanical measurements that I do, and it's really quite good.
So, but you also have a 2D problem, right? You have this field, which has got a size to it.
Mm-hmm.
And you have the potential of a nonlinearity. So, are you trusting the
Meaning if, like,
linearity?
it's kicked off at some angle because of the third dimension?
No, meaning you turn your XY positioner,
Mm-hmm.
and I guess you're depending on the glass scale for all of X and all of Y.
Yeah.
Wow. So the standard that they give you is like the Holy Grail.
The little glass scale. Yeah.
Yeah.
They actually didn't give us one, although I have some. I have a couple of, weirdly enough, Zeiss slides that I got from something else. They were using a specially made one, which I think went down to like 5 micron increments or something like that, which I didn't even know was possible. I've only ever seen a 10 micron slide, because that's already like packed super close. And to use lithography to, I'm guessing, contact lithography, to get those chromium lines at that spacing with good definition is really, really, really hard. So to do that to 5 microns is kind of mind blowing. But that's what the guy had, and
Wow.
that's what they were using.
Let's see. Blake Terzini on YouTube says, when I have to inspect EGSC diamonds under a microscope, I can focus on different dislocations at different depths. That's pretty cool, but we don't
That
know
is cool.
what is EGSC. You could tell us in the chat. Yeah, that's very cool. What about temperature? Right, you have this instrument that's doing ridiculous things. Should it be in a temperature controlled environment?
Yeah, this is interesting because we're now in the realm where it really matters. And I would say it matters for no other piece of equipment more than it does for our diamond turning machine. But it also matters for the microscope. And so one issue is that, you can have like absolute temperature variations, and then you can have like localized or variable temperature, or sorry, localized or relative temperature variation, right? And the issue with absolute temperature variation is that, the scales actually grow and contract,
Yeah.
right? And so now like your inch is no longer an inch, right? That is something that's like more or less easy to compensate for, because you can, those things around room temperature tend to track pretty linearly,
I
right?
wonder,
Depending on the material.
do they have they must have temperature sensors in proximity to each scale and do some magic in software.
I don't know if they do. Like on other pieces of equipment that we have, like our Zeiss Duramax, the CMM, that just like asks you to input the temperature before you run a cycle.
Huh. Interesting.
And that may also be an option in the measurement software on the Olympus, but I can't remember if that's true or not.
Well, I just appreciate the fact that if we care about fractions of tenths, the real tenths, this thing is like way up to the, up to making those measurements with no sweat.
Heck yeah.
What's your first mission for it?
Oh, actually, what if I may just jump back to the temperature thing? So with our diamond turning machine, we got a thermographer and or thermograph, and so we have
a video, like a 2D temperature measurement.
A 2D temperature measurement, yes, with time and temperature being tracked, and it's a very old school one, which was, I think, made custom for Livermore Lab. So it's got their logo on it and everything, and it came with the machine, and we have a few of them. And I did run a bunch of tests to see kind of like how the temperature in the space that we have all this stuff, like the metrology lab and the room adjacent that has the Kern and the Precitech, trying to see like what, how it tracks over time. And it's really pretty amazing how stable it is. So during the course of a 24-hour period, it usually varies by around 3 to 4 degrees Fahrenheit, which is pretty gosh darn good for having essentially no climate control. We're basically in like a concrete bunker, the way that the building was designed. So it's just that like really good insulation, and that, I guess, the stability of the heat sink of the building itself, which is giving us that stability. And what's cool too to see is that we've got a probe on the spindle and also a probe just in the ambient air of that Precitech. And you can see that there is like a little bit of a lag, and it just takes time for the thermal mass to kind of reach what the ambient temperature is, right? And so they tend to lag each other by a few hours, which I find very, very interesting. So the spindle actually achieves its warmest point like around 10 p.m.
Well,
which is really strange.
So you probably have, that's like almost 6 hours of lag, right?
Yeah.
That's amazing.
Yeah, it's really nuts.
You buried the lead when you said we're basically in a concrete bunker. That's like accidentally perfect.
Well, the people who built the facility really knew what they were doing, and it was purpose built for a shop space. So although a lot of the stuff is outdated now by, like our electrical system is, borderline dangerous. It's the building itself was really well made.
I don't know if you're aware of this, but I played bass for Borderline Dangerous back in the 80s.
I was waiting for that joke.
Yeah, you kind of, if you're going to pitch him over the plate, dude, I'm swinging. Let's see. We had Carl Tauber just checked in saying, sorry, I'm late. Listen, if you caused Machine NZ to be late for work today, we're going to have problems. I'm excited. That sounds pretty neat. So it harkens back to the start of More Special Tool when they made their grading machine, right? This was their breakthrough level of precision, making these it's exactly what you're dealing with right now. You're using the product of that, and they of course built the ultimate concrete bunker, and here you go. So maybe with a little insulation and a little cleverness, we can improve your couple of degrees there, which isn't bad. Well, I think
it'd be pretty cool.
That sounds pretty exciting. What other new goodies have you brought into the program?
I'm trying to think. Since the last time that I was on the show, or whatever we would call this,
I don't know. No, actually, nobody knows what to call this.
The event. Since the last time that I was on the event, I think have gotten a lot of machinery. I think we got the diamond turning machine since then.
Yep.
We also got the white light interferometer for measuring surface roughness. So that's like, kind of goes hand in hand with the measuring microscope and with the diamond turning machine. So this is, kind of like a surface quality inspection, but it does it on like the angstrom level. With the diamond turning machine, everything's on the angstrom level.
Yeah.
So actually, microscope, one of the lower precision pieces of equipment that we have for that machine.
Amazing.
Yeah.
What's your favorite?
My favorite?
Yes, you have to pick a favorite.
Well, I'm definitely crushing on this microscope right now. I've been spending a lot of time with it, and it just keeps unraveling layers and layers. And but to be honest, the thing that I enjoy most is just like looking at the pretty pictures through the eyepieces. I really wish that I could share that with people, but like putting your iPhone into the eyepiece, like, I mean, because you've looked through lots of optics.
Yeah.
And there's just, I see people running around right now with these like USB video microscopes and stuff like that. And I mean, totally. But there's just absolutely nothing like looking through good glass. It's an immensely pleasurable experience.
Well, I've done that for photography over the years, right? I've been a Nikon guy. By the way, I'm not pushing this. Not pushing the non-Nikonosity of your microscope. It's okay. But really, you put truly magnificent optics up to your face, and it's otherworldly. And I know what you're going through. That's fantastic.
Yeah. And I have to say with Olympus, by the way, they're now called Evidence Scientific, which I think is like the world's worst marketing decision ever. But you know what? That's just what it is. Somebody else made that decision. But they were, of all of the people that I contacted, because I demoed a bunch of measuring microscopes and vision measurement systems before we settled on this one.
Yep.
And there were some others that I liked, but this one really was kind of perfect. And it's also what they use in the target fabrication facility for the National Ignition Facility at Livermore Lab. And so that's where I first got turned on to it. They really like theirs. They have a few of them. So not only was it kind of like the perfect instrument, but they were also very, very willing to work with us. So, we paid basically half price for it. And then, they provided a bunch of other support, like applications engineering support and other support for our program. So it was really very nice to work with them. So I'm really happy about it. I did try to contact Nikon, by the way, because they have something sort of similar, an upgraded version of it's like the MM6 or something like that. Measuring microscope, but they were like not having it at all.
No response. That's a bummer.
Yeah.
So my sister, who is a professor of biology, they have dealt with Olympus scopes for years and love them. and also had to withstand all of my Nikon jokes. But they had a great guy, a great rep. It sounds very similar to the experience you're having. So, and we went through this in the electronics world when Hewlett-Packard decided that Hewlett-Packard is now going to mean computers, which broke our hearts, right? And then that became Agilent, and then recently Agilent said, "Yeah, we're changing the name." I was like, "Oh, guys," and they so they changed the name. It's now Keysight Technologies, and Hewlett and Packard are simultaneously turning in their graves. It's just pretty awful, but the glass is good, and that's what's important.
Yeah, it's like it's the same company. They own all the factories. They're like primarily an optics company, right?
Yep.
Whereas there are definitely some like metrology instrument manufacturers that are like they're about the instrument or they're about the software, but not necessarily about the optics. And Olympus is definitely about the optics, and the other stuff is actually kind of secondary. Although I think they do a really nice job of it.
Outstanding.
But yeah, now Olympus still exists, but now they're only doing like the medical stuff. So I think they're like primarily making, endoscopes, things that you stick up inside of your body.
There's so many opportunities. I'm just going to let them all pass. Just okay. So, well, that's good. It's a weird business decision, and I don't know enough about it, but as long as the optics are good, we'll accept it. Yeah. And they are fluoride elements in those lenses.
I guess so, right? So with microscope objectives, there are various different grades, and it has to do with the level of correction for the various aberrations, primarily chromatic aberration, spherical aberration. And so you have achromats or achromats, and then you have your fluorites, and then you have your apochromats. And fluorites are sometimes called semi-apochromats. So they're like, almost completely corrected for those things, but not quite corrected. And there's actually some reason to prefer those because the apochromats have so many lens elements in them that sometimes you start getting other kinds of issues just from having so much glass. It's very complex. But I guess that it must be because they're using these fluorite elements. I mean, it's kind of the same thing, I guess, for like telescope objectives, right? You can have like a semi-apochromatic telescope objective lens if you mess around with the different kinds of glass and their dispersions.
Pretty cool. Pretty amazing. Yeah. So how does it work in your lab where you have students, they're going to have access to this wonderful tool and other wonderful tools? Do you have like a system where they have to get checked out on a particular tool by somebody who's authorized to check them out, and then they get their microscope chit and off they go?
Yeah, so it will be formalized like that. I mean, it's pretty straightforward to use. The measurement software takes a little bit of training, but the microscope itself is pretty straightforward. So it would just be like a get checked off on it by me kind of thing. And that's, maybe like 3 to 5 minutes of talking about the microscope and talking about some of the things that you can do to destroy it and not to do those things. But, that's part of the reason we got the long working distance objectives. I think it would actually be kind of hard to mess it up. Although I say that now, they'll find a way.
Well, yeah.
So one thing is that we haven't really integrated it into our curriculum yet. So we purchased it for this the machining 214 class in particular, which is that micro machining and ultra precision machining class. So in there, it's more or less obvious how we're going to use it. But in the other classes, now I'm now starting to realize that there are many opportunities for us to utilize curriculum, and I think that technology should be taught early on. It's like our optical comparator. They do similar things, but in slightly different applications. And so that's not really ironed out yet. But I think it'll just be that kind of get checked off on it thing. That's sort of the rule that we have with any of the machines in the shop, actually.
So Almost Machining says a 1 degree C change, a 1 degree C changes the scale by 0.00000 blah, 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 or about 0.0001 millimeters. So you get, he's basically saying you get 2.5 degrees Fahrenheit to play in. That's pretty tight.
Yeah, it's not like a huge. I guess it's not. It depends the distance over which you're measuring, right?
Right.
So it's always like the size of the temperature variation and the distance over which you're measuring, and of course the coefficient of thermal expansion of the specific material. So changes, like small changes around room temperature, over a small area, like we're just measuring the diameter of a microscopic hole, like it's actually not really going to factor in all that much. But if we're measuring over like a 4-inch envelope, then it could factor in. But again, it's like he was saying, they're pretty small values. So if a tenth of a micron is going to kill you, I would almost say like it's probably really not the correct measuring tool for that if you're going to that level of precision.
Yeah, what we like to say that your precision needs to be 10 times your measurement, or 10 times better than your measurement. So you're good to a hundredth of a micron. 1 micron. You're good to 1 micron.
It's interesting because I have, like, when I double check the measurements, the optical measurements to mechanical measuring methods, I am getting like, plus or minus a micron, depending. There's like some, somebody was telling me that when you get down to past a certain level of precision, the measurements are sort of stochastic in nature. So meaning that they're essentially just statistical. So you take a bunch of measurements, throw out the outliers, and then take an average, right? And that's kind of what your number is.
It sounds right. When you get down to the Planck length, there's a problem.
Yeah, there's an inherent problem. Yeah.
There's a very inherent problem. So let's pop up 10,000 feet and talk about sort of the overarching picture here. So how many different courses are you putting together, or is it just this one main course? Give us the picture of how the school is working in your department.
Yeah, sure. I guess I've never talked about that. Like if you look in our brochure, you'll see that we have a program of study, and it involves, where's my hand? It involves, it's mirrored.
What do I do with my hands, Coach?
So it involves 3 levels of manual machining, 3 levels of CNC machining. There's, and then there are a few standalone courses. So there's like a print reading class. There's the CAD class. There's a technical mathematics series. Oh gosh, I'm blanking. I think that's pretty much it, dude. I think I know that we also require our students to take an introductory welding class so that they understand kind of how the material behaves when it's being welded on. And then we've got, so that's our like basic course sequence, although we've also added to this. So we added a geometric dimensioning and tolerancing class, and our micro machining and ultra precision machining class, which is all, curriculums more or less written. It's been approved by the state. It's ready to go. I'm just trying to get our administration to let me run these classes, which they seem hesitant to do.
Well, I think it's awesome. And if I was in your state, I would write my congressman and I would wave my fist in the air.
I will give you the email address of our vice president of instruction, and you can send emails to her directly.
Okay, I shall. Because it's not that I like to start trouble. It's that, no, actually, I like to start trouble. I just realized that's truer than you think. So if we have any questions, guys, we have guys on Discord, and we have guys on YouTube. You guys are welcome to pop your questions in for Adam. Otherwise, we're just going to keep making stuff up, which we're pretty good at.
I can tell you about some of the. I'm changing some of our core courses, so it's not just adding advanced courses. I'm also revisiting some of our core, more entry level courses. And there's like actually a philosophical change or shift that has occurred that has made me decide to go a different route with those. And I'm very happy to talk about that.
I would like to hear about that because, my picture of how machining has been taught is it lags by 20 years compared to industry. And I think we're catching up. I mean, let me say, I think the people we hear about working on education are leading us to believe it's catching up. And I'd like to believe that too. So
that's
the fact,
interesting.
you're introducing stuff that's on the bleeding edge of precision and technology, and I think that's very healthy.
I appreciate you for not saying cutting edge because that would have been too easy.
I said I put them over the plate, but not all of them. Cutting edge technology. Yeah, that would have been weird. So I'd like to hear more. Yeah, I want to hear more about what you're up to and how you're doing it. I mean, how many 1940 machines are still in your shop?
1940, probably just the one.
Which one?
Have that would be the old Monarch, the 65 series, I think it is, that we have in the back. Long machine, definitely for shaft work. Not sure where it came from. I think it's been there forever.
Yep.
Nobody building was probably built around it,
I was going to say nobody wants to move it.
No, that's why it's still there.
Keep that machine working.
One of the retired instructors, like I had just mentioned casually that I was, thinking about recovering that real estate somehow, and he went way off on me.
Really?
Yeah, and he was like, you know what? But dude, we never use it. I said, but having it there in that window says something about our program. And I thought, what does it say, man?
It says it ain't going to blow away in the wind.
It certainly says that.
Oh my God. Tucker has a question from Buffalo, New York. Adam, what's your favorite machine or tool? Still the Kern? ? Or some of the new inspection equipment to milk your fancy? Nobody knows what that means, Tuck, but we understand. So what's your favorites?
It's like asking me to pick a favorite child.
Actually, yes, it is.
Yeah.
And we are.
They all have their special place in my heart.
Oh, here we go.
I love all the machines that we brought into the shop recently. I'm definitely attracted to the diamond turning machine and the Kern most of all. And then, the metrology equipment is super cool. And I'm sort of rediscovering a love for some of our other equipment that we've had for a little while longer, like rediscovering the Zeiss Duramax, playing around with that a little bit more. I really also love the Myford cylindrical grinder that we got last semester as well. That thing is a beast. Neat. It's got a little worm wheel fine adjust on it that increments in the wheel head by like 25 millionths of an inch. It's like a half a micron. It's amazing. And it actually does it. I put an indicator on it and it really does it.
That's too cool. Hey, Machine New Zealand, have a great day at work. So Machine New Zealand traditionally joins us for the PFG.Live and then has to run to work because it's New Zealand. And Adam, he says, thank you. Is he gone yet? Can we talk about New Zealand now? Just kidding. Well, now you can start measuring stuff that you're doing on the. I mean, all the hyper accurate goodies that you've recently acquired can now all work together, can all play together.
Yeah, exactly.
Right. You could start inspecting the work of the Kern on the. I'm sorry, it's an Olympus. I'm going to call it an Olympus. That sounds pretty neat.
Yeah. There's the old adage, right? Like you can't make what you can't measure because you won't know when it's been made.
That's right.
And it's so true. Like we had the Kern and we had the diamond turning machine, but we're kind of just flying blind and saying, well, if the CNC machine says that it's the correct size, and it must be the correct size, but it turns out that it isn't always. And you really need that feedback. And so now we've got it. The one thing that I will say that we are missing, that I'm trying to work on, and this is, oh gosh, this is so far outside of the realm of what most machine shops have in their shop. Um, but it's something that you need when you're working on a diamond turning machine. Is we need a Fizeau interferometer to be able to measure the form accuracy of optics. That's a very expensive piece of kit. It most definitely does require an environment that is temperature controlled and controlled for vibration and air turbulence. And it's not even just the machine that's expensive. It requires so many like little optical accessories, like basically everything that you want to measure. Every different kind of conic section or whatever that you want to measure requires its own set of accessory lenses, which is really a pain. But we need
what
it.
size piece of work would you be interested in measuring?
So the diamond turning machine is a Precitech Nanoform 250 Ultra. So it can do 250 millimeters, basically 10 inches. I doubt that we'll ever do anything that big, so I'd be happy with like 6 inches. But you got to imagine like this isn't always true, but essentially like your reference optic in the Fizeau interferometer needs to be at least as big as the thing that you're looking at, the thing that you're trying to inspect. So you imagine like a super high precision 6-inch optic is going to be very expensive and difficult to obtain.
Yes. Well, maybe that's a school project, is to build a Fizeau interferometer. I know somebody who's been thinking about that for many, many months.
Yeah.
That could be kind of cool.
I did build one of those, but it was the most simple version, essentially just a gauge block interferometer, where the reference is just a flat reference, right? So in principle, it could be scaled up, and we could use, like a reference sphere or something like that. But my goodness, that's a lot of work.
Yeah, it would be. Almost says, are you creating simple yet precision parts that the students are able to use those machines effectively across the range of machining and inspection? Are you having the students create small precision parts and inspect them? Is that part of the curriculum?
Yeah, I mean, I really should talk about the overarching changes in the department.
Please do.
Yeah, so I will just say for the micro machining, ultra precision machining curriculum, definitely students are going to be turning their own mirrors, basically. And then for the micro machining component of it, we've actually gone back and forth on what project they're going to work on, but it's going to be, kind of watch-sized stuff. And I think we are also going to try to incorporate some milling of ceramics and stuff like that into that course, because we also got a lot of tools donated to us from 6C Tools. And so those are kind of perfect for micro machining of technical ceramics and things like that. So maybe machine some zero dur, maybe machine some silicon carbide or silicon tungsten carbide, right? I mean, I was joking with the guy the other day, and I was like, well, maybe we can machine some carbide. He says, man, we machine carbide all the time. It's not that interesting. Our tools will last, like 1,000 lifetimes milling in tungsten carbide. And I was like, well, I understand you want to do something more interesting, but I happen to have an endless supply of tungsten carbide in the form of broken end mills in my shop. So I'd like to recycle them.
Can we just take a moment and realize that this guy is talking about tungsten carbide like it's 6061? It's like, dude, that's just boring.
It's so boring for them.
That's amazing.
But it's very impressive to my students, right? Because you chuck up an old end mill and they just start milling stuff out of the back side of it. It's pretty cool.
It's pretty mind blowing.
It's very impressive. We even just like drilled a hole into the back of an end mill, and my students' minds were blown. Like that's all that it took.
I would like to also see that. Let's see. Tuck says, can you turn a glass lens with your diamond turning lathe for your telescope or other applications?
No. There are some materials that are not considered diamond turnable, and glass is one of them. Although there have been some changes, there's some new technologies in diamond turning that allow you to machine glass. Like, for example, the ultrasonic heads, like the Ilsonic made by Innolite, which is it oscillates the tool at like 120 kilohertz, and allows you to machine glass, steel, things that you typically wouldn't be able to diamond turn. And then there's also the laser assisted machining. So there's, oh my gosh, I can't. Lam Research. No, what is it? I can't remember. Lam something. Anyway, they make a laser assisted machining head. They actually shoot a laser through the diamonds so that it focuses at the tip and sort of like softens, thermally softens the material directly at the tool tip, which is kind of cool. So with those technologies, you can do stuff like that.
Would that be an annealing? Kind of.
I guess so. I mean, yeah, when you heat things up,
yeah,
they get softer.
They get softer.
Yeah, maybe it even gets them up to melting temperature. I'm not sure.
That's fascinating. Flat Lapper says, we used to measure 200 millimeter OD with a P2 unit, profile only, plus or minus 0.0001 millimeter resolution, I think. Interesting.
What is a P2 unit?
Yeah, what's a P2 unit, dude? We'll find out in a minute. Have you had any students like just latch on and like, as a teacher, I am certain that you have seen the light turn on inside of a student, and then their whole future just launches. Have you seen this in the micro machining, high precision stuff that you've been doing with Definitely. Any particular? That's very cool.
Definitely. So I'm now starting to, I was learning how to use the machines, and now I'm at the point where I've still tons that I need to learn, but I can start kind of, learning side by side with someone else, right? So there are a few students now who are starting to learn the kern, starting to learn the diamond turning machine. I have one student in particular, Masako, who she's super, super into the concept of precision. And when she first saw the diamond turning machine, she just, it's like a shiny bauble that comes off of this, but she was like mesmerized by it. And so she's like committed to learning how to use this freaking machine. So she's been helping me in the shop. And so that's been really, really cool. And I'm sure that there are going to be more students like that. Some students don't really have a context for it, or they're scared of it. But there are other students who understand that in order to take it to that next level, and this is usually students who have like already been working in a shop for at least a little while, and they're really interested in taking it to the next level.
Carl says, didn't you just show a guy who wants to make watch parts on the kern? Do we know any guys that want to make watch parts on a kern? I don't know.
Yeah, that was Andre. Yeah, he's another one of those students, and he's kind of amazing. He does so much of this work at home. Like Heidenhain has this learning software that you can use. I forget what it's called now, but it's their learning software, and then they also have their manuals, operations manuals, programming manuals are really, really good. And so he's just been going through that, like going through all the exercises like you're supposed to do, but nobody actually does. And his rate of his rate of knowledge acquisition has been extremely high. And then he comes in like 3 times a week to just kind of practice programming the kern. He finally made his first part the other day, very simple, but he's already got another, like it's like a 3x version of like a spoked gear wheel that would go into the train of wheels in a watch. So that's kind of where he's going. It's really cool to see people take after it. And right now it's just on that like one-on-one basis, doing what we call a special projects laboratory. But, this is all stuff everything that we learn from this will be integrated into a more standard curriculum. But I actually really love it when students come in and do a special projects lab when we get to work together like that, because it always pushes my knowledge, right? And the students have a very high level of ownership of that curriculum because they're not just interacting with something that is already prescribed.
Do you have anybody at, like, for example, Berkeley or NASA or wherever that's kind of hovering, like we're waiting for some of your superstars to scoop up?
I mean, definitely. Like in terms of employers who are, looking for recommendations.
Yeah, that's a little. I mean,
Sure.
yes, that's what I mean. I mean,
Yeah,
I
my
think
students are in extremely high demand right now.
that's awesome.
Yeah, they're getting picked up like in their first semester in some cases, and certainly by the end of their second semester if they're looking for work. Although some of them elect to go through the entire program before they go looking for work. Yeah, there just aren't that many people doing this kind of stuff, and certainly, finding someone who is, can show up to work on time and is enthusiastic and has aptitude and has a little bit of knowledge under their belt, and that's even more difficult with the like ultra precision type stuff, right? So there are places around us that do optics and use diamond turning machines for non-optical stuff like micromechanical type work, and it's just very, very difficult to find a person with the right kind of brain for that, I guess. Someone who really is like that detail oriented, right? That they want to focus on like every tiny little aspect of a process, because there's no way to do good work if you just kind of assume it's going to turn out okay because the CNC said it would.
Well
You
put.
have to be a detective.
Um, almost says, is there a part of the class for refinement or process improvement? Is it pretty much the CAD CAM system creates it? It's already as good as the software machine can be. So, do you guys focus on process improvement as part of the class? I think that's what he's asking.
So the measurement feedback will affect the various different settings that we can make on the machine, in terms of wear offsets and things like that. But it'll also affect the machining strategies that we use, right? Some machining strategies are capable of producing better precision and with a higher reliability. And so like in these cases, like speed is actually not like the most critical thing, because you always lose the most amount of time on rework, right? So just getting it right the first time, even if it takes a little bit longer, is the way to do it. And so in that sense, but if the machine isn't making the part right, then there's an issue with the machine. And so the parts become sort of like the smoking gun there, but then we have to go back and do something about the machine. So then I would have to call Kern and shake my fists at them.
or find out it's the operator.
It almost always is the operator.
Yeah. So Dan is bumping Unix Carbide's question. He said, this is the question: are there any books about machine design principles that a bunch of sophisticated 3D printer builders can learn from so they're not reinventing the wheel? What would you recommend? Precision Machine Design by Alexander Slocum.
This is the one. This is the one that's got all the stuff in it. It's quite a bit more than someone building a 3D printer would need. The machine tool world is always a trade-off between precision design, like instrument design, where the forces are very, very low, but precision requirements are high, and structural design where loads are high, but precision is low, right? So it's always a trade-off. And in 3D printing, I mean, there aren't any cutting forces, so the only thing you're really dealing with is weight and acceleration. So it's definitely overkill for what you would need to build a 3D printer, but everything is in that book for sure.
We like overkill.
We do.
We're all here for overkill.
I want to see like a 3D printer with like a cast iron base, scraped dovetail ways.
Yes. Yes. Well, why can't we take like an old Cincinnati mill and put an extruder on it? I think all of our machine stiffness arguments would go out the window. That would be pretty fun.
It would work really well, and it would be so slow.
Carl, I will take the information from Adam and put it in the video description for you. Promise, and maybe even pop it on Discord.
Do you mind if I talk a little bit about the, what I mentioned earlier, the sort of like changes to the core part of our program? Because I think that actually might be interesting, and I think I might catch some flack for it, which I'm also excited about.
Yes, we. Please proceed. If it's something you're going to catch flack on, I absolutely want to hear about it. But before we do that, I just want to remind everybody that you're listening to PFG Live, brought to you by PFG Stones, who want to remind you that there's flat, and then there's flat. We're talking with Adam Balogh of Laney Machine Tech, talking to us from the San Francisco area. Mm-hmm. And we're enjoying it. Let's see. There was somebody who turned a CMM into a 3D printer. That would be
great, actually.
Yeah, that sounds pretty awesome. So please, and one other thing I want to point out, since we're coming up to the top of the hour, I promised to talk a little bit about the Adafruit little widgets that I have had some success with this week. But you know what? I think we may have to revisit that because we're running out of time. I might be able to stick some in at the end. So the flame gates are open. Please proceed.
So I think people who follow the account on Instagram are familiar with the new project, the Finder Scope project that we're doing. That's actually the introductory project. So students in the very, very introductory class are going to be making that all themselves. But it's going to include more than just manual machining skills. It's also going to include a little bit of digital fabrication. So there'll be a CNC machine part, there will be a 3D printed part, a laser cut part, and a water jet cut part that goes into that to make this small refractor telescope with an altitude azimuth mount on it. And so in order to be able to go through that project, I mean, the whole idea behind that is that the projects that we've done in the past have been sort of like widgets. They're just exercises, they're paperweights at the end of it. Mm-hmm. And, you'd always like to make something that actually has a function afterward, although it's actually very difficult to design a project so that it is an actual functional object and also hits all of the like points that you need. Like, I think a lot of courses end up doing like a hammer or something in the first class, which I think is actually like not a great exercise because there's no precision involved in a hammer. So this was our alternative to that. We also decided against doing like more like machinist tools. Like I know some programs are doing like spring-loaded tap guides and vice stops and stuff like that, which are really great projects. But to someone who's not a machinist, they don't mean anything. And whereas a telescope, I mean, like anyone can look through it. They understand what it does. And so that was kind of our idea there, right? We wanted something that, would you can show your friends, you can show your family, and they'll be impressed by it.
And they'll probably have it on their mantelpiece for 40 years. I mean,
even if they never take another class, right? They'll have that as
I made that
a memento.
Yeah. I mean, everybody has those things. Actually, in the background, on this frame, you could actually see it in the background. That whole shelf is like little widgets I was involved with, and everybody likes that stuff. So I think that's an awesome idea.
That's not the controversial part of this. Our
please
program,
stand by.
Our program is, it was modeled after essentially the Mare Island Naval Shipyard apprenticeship curriculum. And so it's very, you were talking about how machining education lags by 20 years. I think that in terms of the technology that people are teaching, that may be true. I think that in terms of the methodology of teaching, the pedagogy, I think it lags by maybe a century, right? Where the old apprenticeship system is, people come in and they do, high speed steel tool grinding. They do, they use a drill press, they use layout procedures, all that kind of stuff. And I think that's based off of this idea. There's this very prevalent idea in the trades that, you have to pay your dues and you have to learn the old ways before you can learn the new ways. I actually think this might be like a logical fallacy where people assume that in order to learn a trade, you have to learn it in the same chronological order that humanity learned it, right? Where you don't want to start with the current technology, the modern technology. You have to start with the old stuff so that you can learn how we got there.
Mm-hmm.
And this is the thing that I think I am now starting to disagree with. And this is kind of the shift that I'm making here. So I actually removed high-speed steel tool grinding. I removed the drill press. We also used to teach people how to, use dial indicators on the bedways to tell where your carriage had been positioned. And learning how to read the dials on the cross slide is the very first thing that you learn. And I'm not saying that students don't need to know that. Those are extremely important things to know. But we are moving that into the second class. So the second class is going to be a sort of hardcore skill building class now, and we're going to make some widgets in there, right? I'm going to teach them how to sharpen a drill, how to do high-speed steel tool grinding, reintroduce the, using dials and the concept of backlash and things like that. But in the first class, we are going straight to the more modern stuff. So that's the reason why we installed digital readouts on all of our machines now, and so students will be using DROs from day one. They'll be using carbide, right? They are not going to learn how to use a drill press to do any kind of precision features. We're going to go straight to the mill. And so the idea behind that is that for somebody who comes into the program who already knows that they want to be a machinist, the apprenticeship model really, really works because that person is ready and receptive. They're like, teach me everything. I want to be good at this. But what we're noticing more and more is that the students who come into our program have less and less background experience in things directly having to do with machine work. And so for those people, we are getting them at an earlier part of their career where they're not even sold on this stuff yet. They may have seen a YouTube video and they thought it looked kind of cool. And so what we want to do is get some wins under their belt. So instead of starting them on the hardest, most caveman methods for doing something, we're going to get them started on the ways that get them those wins under their belt as quickly as possible and make some cool stuff. And then in the second class, if they sign up for that, I'm going to assume that they really do want to learn how to get good at it. And so that is the philosophical shift. And the reason why I developed the Finder Scope project and the reason why you see a lot of changes in our shop recently.
I really like what you're saying. And what I'm realizing is that it applies to other fields also. So I have other fields that I'm deeply involved with, namely electronics and radio communications and antennas. And we have a similar analogy where these days you can buy a little digital signal processor for cheap and then write some software to make a radio and demodulate a signal, and it's the same thing. It's like, should you do that first? And what the magic words you said were quick win. Here's a student, give them a win, and it's not a cheap win, right? It's real skills, and they're doing something real, and you set the hook. Whereas I think, I think if you say, like one of our guys here, where is it? I want to get that comment. Oh, Indiana John said, so you don't think students should first start with hand files?
Nope. I've changed my mind about that.
And that's huge. That's flipping the whole thing, which I think has a lot of merit. It has a lot of merit because you got a student who spends, N hours a day in front of a screen, large or small. They're used to high tech. And now if you give them something high tech and they make a widget, you might have a believer, and now you can go on. I love it. I think it's a great idea.
It's a bit of a gamble. It's assuming, right, that once somebody gets hooked on it, they're going to want to learn the other ways, right? And some of these things we're only learning is like like first principles approach, or like a rainy day approach, right? Like if I don't know, the DRO goes down, are you going to be able to make your part? So those kinds of ideas, right? But that's a bit of a gamble. I don't know if students are going to actually be receptive to that. And I would feel I would feel so bad if there was an entire generation of students that came out of my program and they didn't know how to use a hand file. That would be straight up embarrassing. So it's definitely something that I want to bring back. It's more just about what do we start people with, and trying to, like you said, get that hook in them as early as possible.
And
but
also,
it's a big experiment. We'll see how it goes.
You're showing them where you're going. It's like, a friend of mine used to say, start with the end in mind. What's the end game? Well, the end game is we're going to take these super precise, amazing machines and make something ridiculously useful that may be useful to us going to Mars. Right? It's like, who doesn't want to do that? And then you can get down to the nitty gritty. I think it's a pretty cool idea. So you have my complete support, especially since I'm on the other coast and I could hide under a table. New York machine. Sorry, go ahead. You're muted. You're muted. No, I'm kidding. I was joking.
I take those things seriously. I'm in Zoom meetings very often.
The most common 2 words in the world right now are "you're muted,"
or the most common 3 words. Oh, no, that's 4 words. Put yourself on mute.
Yeah, but if you're running the meeting, you have the hand of God anyway. Click.
That's true. That's true. Although not every mediator knows that.
New York Machinist says, that's an awesome program perspective. I didn't visually see a CNC machine until my 3rd or 4th semesters in a CNC machining degree. And he thinks this is a great idea. Robert Simpson says, having only recently installed a DRO, I would hate to go back to dials and Sharpie lines on the saddle.
Yeah, it's hard to go back. It's definitely hard to go back.
Well, that is pretty cool. Let's see. Unix Carbide acknowledged receipt of your book recommendation from the beach at Coney Island in Brooklyn, New York.
Wowza.
That's pretty cool. Which, by the way, is where I grew up. So that's weird. It's weird. The universe is, it's weird. I
did want to, the thing I wanted to say earlier is that there are many different like pedagogical strategies, and like one of them is actually, like 2 paths that you can take. You can start with the simple and build up to the complex, or you can start with the complex and break it down into the simple. And what we were doing before was definitely the former, and what we're doing now is definitely the latter. And so from, maybe that makes sense in terms of like an overarching philosophy.
So another example from my life is aviation, right? You say, hey, I want to learn how to fly. So what's the first thing that happens? First thing that happens is you go with an instructor and you go fly. And in fact, in airplanes or gliders, which is where I learned, on that first introductory flight, they say, take the stick, you got it. And you're flying an aircraft. And you don't know what you're doing. You don't know how to do it right. And the guy behind you or next to you is going to keep you from killing yourself, but you're doing it. And that's what it feels like. It feels like, here's the wow factor. We're going to hold your hand. We're going to make sure you do it right, but do something with, at the epitome of this skill. And then if you make it through that, it's like, okay, let's figure out what we did. I think it's brilliant.
Yeah, that's like that's exactly it, right? Because that's giving you that crucial context for what it is that you're learning, right? So like if you grind tools before you cut with a tool, then like you have no context for what you're doing when you're grinding that tool. It's also the reason why I decided to institute these beginning of the semester field trips to machine shops. We just did one at Astra Space in Alameda, California, with
Neat.
my introductory course, my 2 introductory classes. So that's about 60 people who we had go through there. And I didn't know if it was going to be overwhelming from them or for them, but we kind of created like a discussion prompt on our online learning management software, and the responses have been really, really great, very insightful. People definitely got a lot out of it, and we'll be unpacking it for the rest of the semester. But it was a great way to give people a context and give them something to aspire to, so that they know what the eventual end goal of their program is. We only ever used to do field trips like at the end of the semesters, or actually at the end of the academic year,
Right.
Around the time when students were starting to look for work. But by that time, you've already lost all the people who like didn't have a context for it and weren't really into it. So hopefully this is, again, that way to capture people earlier on.
I love it. What's your philosophy? You need a catchy name for your philosophy here.
I'm sure it already exists, and I just had to invent it myself. But okay. I'm sure that it's actually a very common thing. I'm just ignorant of the literature.
Well, this is awesome. I think we did it, and I want to thank you for bringing that to today's discussion. It's really very hopeful. And I hope that we light a fire under some young folks that decide they need to go do this and become precision machinists and experts in the field. All of our interests going forward, in the space program, in technology is going to save us, all depend on them. Not that they should feel any pressure or anything, but I think it's fantastic. Well,
the trade really depends on these people coming in right now.
Yeah, because I hear a lot of comments about people not being able to find skilled machinists anywhere. Okay, let's wrap it up. Thank you, Adam. Thank you for being here. I may actually change our thumbnail and video description to completely drop the stuff that I was going to talk about the sensors, and we'll just do that next time. And that is a totally excellent solution. Robert Simpson says, DRO makes it easy to backwards. Indiana John, your aircraft, my aircraft. Absolutely. Almost Machining says, thank you for having Adam on, and keep it going. Happy to do it. K-Bonk says, thumbs up. Don't forget, great chat, A and S. I have no idea what you're talking about, except Abraham and Strauss was a department store in New York City when I was growing up. Tucker Holiday says, thank you both for the live. Loved hearing about tiny measurements. My son loved the live too. We're already doing it. We're influencing the young people. Carl, take care. Nice to see you. And Adam, when we click off, just stay on Zoom. I will be right with you. Guys, you're all awesome. We will be back next week for another episode of PFG Live. If you don't know where to find all the episodes of PFG Live, go to a browser and type PFG.Live, PFG.Live, and you'll go right to where it all is. Take care, everyone, and let's see. We'll see you next week.